The group 18 members are also known as what? Noble gases, or it is known as what? Zero group element or inert gas element. It is very interesting to note that the non-metals and metalloids which exists only in the p blocks of the periodic table. Aluminum is only the metal which is belonging to this group, which is abundantly found in the nature. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidyashram Pre University College, Temple of Excellence, Mysore. My dear students, in this session, we are going to start with the new unit called Some P Block Elements. So before going to discuss with this unit, let's see the weightage of this unit. From this unit, we can expect 2 1-mark question, 1 2-mark question and 1 3-mark question, and totally we can expect the 7-mark. And the question number will be goes like this. In the part A, the question number 7 and 8 which carries 1 mark. In a part B, the question number 15 which carries 2 marks. In part C, the question number 26 which carries 3 marks will come from this unit, and totally we can expect 7 marks from this unit. In this session, we are going to discuss with the introductory part of this unit, that is about the P block element, and we are going to discuss with the oxidation state, the general oxidation state of the P block element we are discussing. In addition to that, we are also going to discuss with the group 13 element, which is also known as what? Boron family. In that, we are going to understand the physical property and electronic configuration and properties of the boron family we are going to discuss in this session. So before that, okay, let's see where exactly the P block which has been situated in our periodic table. If you see the periodic table, we all know that the group 13 to group 18, which is known as what? Group 13 to group 18, which is known as what? P block. They are known as what? Group 13 to group 18, they are known as what? P block element. Okay. If I consider only the group 13, it is known as boron family. Why it is known as boron family? Because the first member is a boron. Next, group 14, which is known as carbon family. Group 15, which is known as what? Nitrogen family, and it is also known as what? Pnictogen. Do you know why the group 15 members are also known as pnictogen? Because all these elements are gases and they are too poisonous. When we inhale, it causes a many respiratory problem. Hence, it is known as what? Pnictogen. Coming into the group 16. Group 16 are also known as what? Oxygen family, or it is generally known as chalcogens. Okay, because these are the O's which is found in the earth crust, hence it is known as chalcogen. Coming into the group 17, they are known as what? Halogen. So hope you are familiar with the group 17 member as we have already studied. Coming into the group 18, so the group 18 members are also known as what? Noble gases, or it is known as what? Zero group element or inert gas element. Why they are known as a zero group or inert gases? Because all this element, they have completely filled electrons in its valence shell, hence it does not react with any other element, hence it is known as what? Inert gases. Okay, this is a just outlook about the P block elements in our periodic table. So in your first PUC, you are going to study in detail about the group 13 and group 14. Okay, whereas in your second PUC, you are going to study from group 15 to group 18. So in your first PUC, you need to concentrate only with the group 13 and group 14. Okay, if you consider only the group 13 elements, all these elements, they have a general valence shell configuration of NS2NP1, or you can say NS2NP126, which means to say that all these elements, okay, they shows the last electron which is entering to the p shell, hence, or to the p orbital, Hence, they are known as what? P block elements. So, the elements which are having NS2, NP1 to 6, the valence shell electronic configuration, this indicates that the last electron which are entering to the P block, hence it is known as what? P block element. Elements of the group 13 to 17 and the noble gases are also known as what? Zero group, which constitute this category of the P block. Generally, when we are studying in detail, we say from group 13 to group 17 as a P block, okay, except this group 18. Why, ma'am, it is exceptional cases? Because already we know that all these elements, they have a completely filled electron in its valence shell, hence it does not react with any other element, thereby it does not form any bonding at all, okay. That is why we are leaving out the group 18, and from the group 13 to group 17, generally we say it is P block elements. Coming into their names, group 13, which is known as what? Boron family. Group 14 is a carbon family. Group 15 is a nitrogen family, or it is also known as what? Pnictogen. Group 16 is a oxygen family, which is also known as chalcogen, and group 17 is a halogen, and group 18 is a noble gases. Next is atomic and ionic radii. We are just understanding the general trends in their properties, that is a periodic property. The first trend is atomic or ionic radii. As we are already understood that atomic radii, it is nothing but a distance from the center of the nucleus to the outermost shell of an element, right? So, as we move along the period, that is from left to right in the periodic table, this atomic radii will be decreases because of the increased nuclear charge. As we move from left to right, we already know that atomic numbers which is increases. If the atomic number is increases, automatically more number of electrons are added to the same shell, so that effective nuclear charges are increasing. That is why the distance from the center of the nucleus which is decreasing, hence the atomic radii or ionic radii which is decreases along the period. But as we move down the group, this atomic radii will be increases. That is mainly because as we move down the group, number of shells are going to be added up. As the number of shells are increasing, the distance from the center of the nucleus to the outermost shell, which is also get increased. Hence, it is also get increased as we move down the group. Next is ionization enthalpy. Already we have understood that ionization enthalpy is the energy which is required to remove the electron which is there in the outermost shell of an gaseous atom. But as we move left to right in the periodic table, okay, it will be increases along the period and decreases down the group. Why does increases along the period? As we all already know that more number of electrons are added to the same shell, it is very easy to pick up the electron. That is why, increases along the period. Ionization enthalpy means it is the energy which is required to remove the electron from the outermost shell of an gaseous atom. As we move along the period, it is increases. Why it is increases? Because already we have understood that more number of electrons are added to the same shell, right? As the number of electrons are increased in the same shell, it's not so easy to remove the electron from the valence shell. That is why the energy is required is more as compared with the other element. That is why as we move along the period, this ionization energy will be increases. But as we move down the group, we all know that number of shells are increases, so that the electrons which is there in the outermost shell, that is also get decreases, right? So that is why we can easily pick up the electron from the shell, so thereby it will be decreases the ionization enthalpy down the group. Coming into their electron affinity. Along the period, electron affinity of the P block element will be increases and decreases. Down the group, electron affinity will be decreases. So down the group, it is decreases. Along the period, electron affinity will be increases. Why it is increases? Because of the decreasing in atomic radii or ionic radii, you can say. But down the group also it is get decreases because of the number of shells are increases. Coming into the last trend, that is electronegativity. The electronegativity of the p block element increases along the period and decreases down the group. Why it is increases along the period? Again, this is due to the increasing in atomic radii, and it is decreases down the group, that is mainly because of the increasing in number of shells. This is a general trends in their periodic property. Coming into their metallic characters. If you see the p blocks elements in the periodic table, their metallic, non-metallic as well as with the metalloid characters, we can see that. Okay. So the metallic characters, again it will be decreases along the period, increases down the group. So as we move left to right in the periodic table, then metallic characters will be decreases, but as we move down the group, it will get increases. Why does get increases? I'll tell you by looking at this figure. This is just an outlook of the p block elements. Okay. Okay. If you see the periodic table, you can see that the brown shaded regions, these are nothing but a metalloids. Metalloids means these are the elements which behave like both metal as well as the non-metal. Whereas the pink portions, they are nothing but a non-metal, whereas the blue portions which are the metal. But as we move down the group, you can see that this is a metalloid. Later all the elements have become metal. That is why the metallic characters will be increases down the group. But as we move along the period, this is a metalloid. Again, they are the non-metal. Hence, it is decreases as we move along the period. Okay. And increases in the metallic character down the group. This is due to the increasing in atomic size and decreasing in ionization enthalpy, as we have already understood. It is very interesting to note that the non-metals and metalloids which exits only in the p blocks of the periodic table. So if you see the p block, especially if you see entire periodic table, the metalloids, metal and the metals which is found only in this block. This is another speciality which has been added to the p block elements. So it consists of what? Both the non-metal, metal as well as with the metalloids. Coming into the general oxidation state. So it is very important to understand the general oxidation state of the group 13 to group 18 elements. So first I'll go with the group 13. If you see that group 13, it is also known as what? Boron family. Correct, no? And it consists of outermost electronic configuration of Ns2Np1. You can see that it consists of 3 electrons in its outermost shell. Hence, it shows a maximum oxidation state of +3. In addition to the +3, we can also expect the +1 oxidation state from this group of element. Coming into the group 14, group 14 elements are also known as what? Carbon family, where you can see that this is a boron family, this is a carbon family. Okay. So in the carbon family, you can see that it consists of outermost electronic configuration of Ns2Np2. In the outermost shell, it consists of 4 electrons. Hence, it shows a +4 oxidation state. In addition to the +4 oxidation state, we can expect -4 and +2 oxidation state from this block of elements. Coming into the group 15, which is also known as what? Nitrogen family. Okay, and it has a general outermost electronic configuration of Ns2Np3. In its outermost shell, it consists of 5 electrons. Hence, it shows a +5 oxidation state. In addition to the +5, we can expect the +3 and -3 oxidation state from this block of elements. Coming into the group 16, which is known as oxygen family. Okay. it has general outermost electronic configuration of Ns2Np4. In its outermost shell, it consists of +4, 6 electron. Hence, it exhibits the +6 oxidation state. In addition to the +6, we can expect +4, +2 and -2 oxidation state from this block of elements. Coming into the group 17, which is also known as what? Halogens. Already we have know that. This blocks of elements which consists of 7 electrons in its outermost shell, hence it shows a +7 oxidation state. In addition to the +7, we can expect +5, +3, +1 and -1 oxidation state from this block of elements. Coming into the last one, that is the inert gases or zero group or noble gases you can call. This blocks of element, if you see that the outermost electronic configuration is Ns2Np6, which indicates that in outermost valence shell electronic configuration also it consists of 8 electrons. In addition to the 8 electron, we can expect +6, +4 and +2 oxidation state from this block of elements. Another way of remembering the oxidation state of group 13 to group 18 is, you can remember is group 13 as shows a maximum oxidation state of +3. Similarly, group 14 is +4, group 15 is +5, group 16 is +6, group 17 is +7, group 18 is +8. That is the maximum oxidation state which has been exhibited from this block of elements. Next, we have the detailed study of group 13 elements. So, let us see the first group 13 series of element. The first one is boron, aluminium, gallium, then indium and thallium. Okay. First, the boron family which consists of a non-metal. So, boron itself is a non-metal, whereas the rest of all these elements are metal. Already we have understood this. This is only the non-metal which is found in this block. Correct now? Yes. General characteristics of this boron family are as follows. It do not occur in an elemental state in the nature, but all these elements, they do not occur elementally in the nature and they are scarce in the natures except aluminium. Why except aluminium? We all generally know that aluminium is only the metal which is belonging to this group which is abundantly found in the nature. And they have a 3 valence electron. Already I have explained that group 13 elements, they have a general outermost electronic configuration of Ns2Np1. So, in its outermost shell, it shows the 3 electron, hence their valency which is also become 3. Okay. They are metallic in nature. So, already we have understood that except boron, aluminium, gallium, indium and thallium, all these elements are metallic in nature except boron because it is only the non-metal which is found in this block. And they are very soft and they have a very low melting point. So, even though it is a metal, they behaves like a very soft metal and also they are having very low melting point. But if you see that boron which is very hard and even though it is a non-metal, their melting point which is also very high and they are chemically reactive at a moderate temperature. If you see the general properties of the group 13 element, we can found that boron is only the elements which shows its different character from the rest of the other element. Why boron is showing the different character, that we are going to discuss while discussing the anomalous behavior of the boron. Okay. Next is the electronic configurations of group 13 element. So, already we have understood that the valence electronic configurations of group 13 is Ns2Np1. So, this indicates that in its outermost shell, it consists of 3 electrons. Correct now? Yes. So, we'll see with one by one. Okay. So, boron can be represented as B and the electronic configurations will be goes like this. The helium 2s2 2p1. Next is aluminium, we represented as Al. The general electronic configuration is neon 3s2 3p1. Whereas the gallium we represented as Ga and the electronic configurations will be argon 3d10 4s2 4p1. Next, indium is iron. The electronic configurations will be krypton 4d10 5s2 5p1. Next, we have thallium, that is Tl, and it has a general electronic configuration of xenon 4f14, 5d10, 6s2, 6p1. If you see that electronic configurations from the boron to the thallium, so the last electron which is entering to what? P orbital, the last electron which is entering to the P orbital, and you can see that in its last shell only it consists of 3 electrons in its outermost shell. Next is atomic and ionic radii of the group 13 element. Okay, so already we have discussed that what is the atomic radii and ionic radii of the a p block element. How does it increases or decreases? Let's see in detail study of the atomic or ionic radii of the group 13 elements. Okay, the atomic and ionic radii of the group 13 elements, so it will be increases as we move down the group, and this is due to the number of shells are increases, but as we move along the period it will be get decreases because of the increasing in effective nuclear charge. But it is observed that the atomic radius of the aluminium which is slightly more than that of the gallium. If you write the elements, first is boron, next aluminium, next gallium, next indium, next is thallium. Correct now? Yes. But it is observed that atomic radius of the aluminium which is found to be 143 picometer, whereas for the gallium it is 135 picometer. But we have already studied that as we move down the group, atomic radius should be increased. Why it is increased? Because of the number of shells are increases. Correct now? This can be understood from the variations of inner core of the electronic configurations. The explanation for this is, while going from aluminium to gallium, you can see that there are 10 element differences will be there. Correct no? The first transition series of the D block from atomic number 21 to 30, which have the electrons in their d orbital, and the d orbital do not shield the nuclear charge effectively because of the shape and the poor penetration power. As a result of this, the effective nuclear charge of the gallium, which has become more than that of the aluminium, therefore atomic radius of the aluminium will be decreases slightly. So what is the reason why it is decreasing? Only because as we move down the group from the element aluminium to the gallium, there is a 10 element differences will be there, and all these 10 elements they have a electronic configuration differences with the atomic number 21 to 30. Okay, and all these elements they have a involvement of the d orbital. When the d orbitals are involving, there is a lot of increasing in the effective nuclear charge, we can see that. So that is the only the reason the gallium was effective nuclear charge are increasing. That is why the atomic radius, which is also slightly become lower as it is compared with the aluminium. Okay. Next we have ionization enthalpy. So already we have understood that ionization enthalpy is nothing but the energy which is required to remove the electron from the last or the outermost shell of an electron. Correct? No. Ionization enthalpy of the boron series of the element decreases as we move down the group, and this is due to the decrease because of the increased atomic size. So as we move down the group, this ionization enthalpy will be increases because of the increasing in atomic size, and also the number of shells are being added up, we can easily remove the electron. Consequently, the electrons are become less and less tightly held to the nucleus as we move down the group. Ionization enthalpy which also decreases down the group, and this decrease sharply from boron to aluminium, then ionization enthalpy of the gallium is unexpectedly high than that of the aluminium. This is only the exceptional case. Next we have the properties of the boron family. So here I have represented the each different properties. First is atomic radii, ionic radii, density, ionization enthalpy, electronegativity, melting point, as well as with the boiling point. Let us understand one by one. This is a group 13 elements from boron to the thallium. Okay. If you see the atomic radii, Okay, if you see the atomic radii of the boron to the gallium, that is as we move down the group, it has been increases. Correct now? So as we move down the group, the first element is boron, next is aluminium, then gallium, indium and thallium. So what happens to the atomic radius? It will be decreases as we move down the group because of the number of shells are increases. If you see that ionic radii also, it is increases down the group. Coming into the density. Density is mass by volume. As we move down the group, you can see that density which is also get increases. Okay. Ionization enthalpy. If you see the ionization enthalpy, it is go on decreases. Why it does go on decreases? Because if you see that with the boron as well as with the aluminium as well as with the gallium, next with the indium as well as with the thallium. So as we move down the group, what will happen? There is an increasing in atomic radii. And also, you know what will happen? More number of shells are increases. If the more number of shells are increases, you know, we can easily pick up the electron from its outer motion. That is why, you know, it will be gone decreases down the group. You can see that this is a first ionization enthalpy and this is a second and this is a third ionization enthalpy. That is a first ionization energy, second ionization energy and third ionization energy. You can see that again it is decreases, again it is decreases down the group except in case of indium as well as with the thallium. Next we have electronegativity. Already we have understood that it is going to be decreases down the group and increases along the period. Coming into the melting point, already we have understood that it is going to be decreases. Why it is decreases? Because all this, as we move down the group, except boron, all these elements are metal and they are soft and hence their melting point as well as their boiling point will be become very low. You can see with the boiling point also. Okay. Next we have the physical properties of the group 13 elements, that is a boron family. So boron has a high melting point because it exists as a giant covalent molecule or the polymer in the solid or in the liquid state. So why the boron is exhibit in the non-metal characteristics? Because of its covalent nature and also their melting point will be become very high. And the regular increasing in the trends in the density down the group, this is because of the increasing atomic mass which lowers the weight with the increasing in atomic size. Melting point do not vary regularly and decreases from boron to the gallium, then it is again increases as we have observed. And also you can see that the lower in their melting point. Already I have explained that boron is only the non-metal, whereas the rest of the elements they are metal. Even though they are metal, they are very soft and the melting point which is also become very low. This is due to the fact that they consist of only the gallium molecule which is exits only at the liquid up to 2000 degrees Celsius. Hence they are used in the high temperature thermometer, and the boiling point of all this element shows a regular decreasing down the group. So in our next session, we are going to discuss with the chemical properties and remaining topics of this unit. So what are all the things which I covered in this session? It is only the introductory as well as the group 13 elements. Focused on the group 13 elements. I'll come back with the next remaining part. Till that, take care, be safe. Thank you.